sine and cosine functions, and then going from the graph of a sine or cosine function to an equation for a sine and cosine function. And I'd ask you to work on worksheet 1. We'll start with some questions from that. Did anybody have anything that they wanted to ask about, Mackenzie? So here we're asked to just describe some attributes for the function. Before I can do that, I need to identify the values for a, c, h, and k. So I'm going to start by writing it in this form. Notice that the inside of my cosine function is not the same as the general transformation. So I'll start by factoring off a negative 1/2. So negative x over 2 divided by 1/2 is positive x. Negative pi over 4 divided by negative 1/2 is going to be a positive. And then pi over 10 divided by 1/2 is the same as pi over 10 multiplied by 2. So in this case, my a is positive 1/2, my c is negative 2, my h is negative pi over 5, and my k is 1. So we're also asked for the amplitude. Well, the amplitude is just the absolute value of a, so that's just 1/2. The midline, which is y equals k, so here we have y equals 1. The period, which is 2 pi times c, so in this case that's going to be 4 pi. And then the frequency, which is the reciprocal of the period, so 1 over 4 pi. And then I think it also asks to describe the transformation in words. Mackenzie, do you need to see that part, or are you good? Okay. And just was going to be a lot of writing that I just didn't want to have to do if it wasn't interesting for us. Were you good with what we did there, Mackenzie? Was it just a factoring piece that you want to double check? Again, the nice thing about that factoring piece is you can always FOIL it back out just to double check, right? So no big deal. Anybody else with questions? Yeah, Evan?
You just do number 1 on that worksheet.
Yeah, so it's like the same thing as number 8, like what we just did.
Yeah.
So the a is negative 1, the c is 1, the h is negative 2, and the k is 0. So there was no factoring that I needed to do to start this one because the leading coefficient on x was already 1. So the amplitude is just the absolute value of a, so that's 1. The midline is y equals k, so that's just y equals 0. The period is 2 pi times the absolute value of c, so that's just 2 pi. The frequency is 1 over the period, so that's just 1 over 2 pi. And then the transformations in order. The c doesn't do anything. So the a, we have a reflect on the x-axis. And then we go left 2 from the h, and that's it. None of the other pieces are doing anything. Okay with that, Evan? Okay, Mackenzie? 13, you say? Sure.
That's good.
Hello. He's absent.
Okay.
Okay. So I'll start by identifying my values for A, C, H, and K. Just like before, that's going to mean that it's going to be necessary to factor this out. So I factor out the 2, so 2x divided by 2 is just x. Pi over 2 divided by 2 is the same thing as pi over 2 times 1 over 2. So that just becomes pi over 4. So my A is -3. My C is 1/2. My H is pi over 4. My K is 0. So the amplitude is 3. The midline is y equals 0. The period is pi, and the frequency is 1 over pi. And then using that information, I'm going to write my transformation map. So it's Cx plus H, and then Ay plus K. And I'm going to perform that transformation on the 5 key points for sine, which I gave you guys in your notes. So when I plug 0, 0 in, I get pi over 4, 0. And when I plug pi over 2 in, I get pi over 4 plus pi over 4, so that's pi over 1/2. And then -1. I plug pi in, that's pi over 1/2 plus 1/4 pi, so that's 3/4 pi. And then 0. And then that's 3/4 pi plus 1/4 pi, so that's a full pi, and then +3. And then 2 pi is a full pi plus 1/4 pi, so that's 5/4 pi. And then 0. So going to plot these, it looks like every major grid line is 1/2 a pi. So 1/4 pi must be like in between the major grid lines. So there's 1/4 pi, 0. 1/2 pi, -3. 3/4 pi, 0. 1 pi, 3. And then 5/4 pi, 0. So I'll draw my graph. And then we asked you to like fill the space, so extend this. So I'm not going to generate any more points manually. I'm just going to kind of follow the pattern that we've established. So let's see, the next spot should be down here, and then back to here, up to the middle, down to the middle, up, middle, down, middle, up, middle. So like this would go like this to fill. And I'd have to do the same thing over here. So up, and then middle, and then down. So I'd look something like this when I'm all finished. Is that okay, Mackenzie? And again, for like the blue piece here, I would want to see like the points still on the graph, like where you actually put the dots, but you don't need to like write down the coordinates or anything anywhere. I just need to see like, or I would just want to see kind of what you extended it to. And I don't know what I did here. I goofed this up, huh? Just a little bit. This spot should be here, and then there. There we go. That's better. Thought that looked goofy for a minute. Okay, anybody else on this assignment before we move on? We can always come back and talk about it more, but they're all kind of the same, right? All the problems are basically the same thing over and over again. Nothing really tricky is going to happen. So today what we'll do is we'll start by doing another example of going from graph to equation. We had talked about how to do this before the last time, but we're going to ask you to do this process in the homework, so I figure we should probably go through and do another example because it can be kind of tricky sometimes, at least especially for your first time doing it. Okay. So the first thing I like to do is to identify the midline. So remember, the midline kind of divides the graph in half. If I look with my eyes, it appears that that midline is here at y equals 1. You guys all agree with that? And that's nice because the midline gives me the value for k. And I guess before we get going too far, so for a situation like this, we're writing the equation from the graph. There's really infinitely many possible answers. You can write these as either sines or cosines. It doesn't really matter. But I'm going to make a little space for each of them. So I'll do all my work for the sine part on one side and all the work for the cosine on the other part. So right away, the k value that we just found is the same for either sine or cosine. So that's nice. That's already squared away. Next, I'm going to go and find the value for a. To do that, I need to look at the amplitude. So the amplitude was the distance from like an extreme point, a max or a min, back to the midline. So the midline is at 1, that maximum's at 4. So the amplitude there was 3. So I know that the absolute value of a is 3. Now that implies that a could be positive 3 or negative 3. I'm not sure which one I'm going to want to use yet. There's a correct answer though. Actually, there's infinitely many correct answers where the a is positive or the a is negative. But I can kind of make this process a little bit easier if I wait to make the decision of which one I want to use in my answer till a little bit later. So I'm just going to write down the absolute value of a is 3, and then we'll come back and figure out whether we want to use the positive 3 or the negative 3 in just a little bit. Okay with that? Next thing I'm going to do is find the period. So the way I like to do the period is I like to just count from extreme point to extreme point. So I'll go from that min to that min. So the first one is at -1¼ pi, and the other extreme point is at -1/4 pi. So the period there just must have been pi, right? Let's go from -1¼ to -1/4. You went 1 pi units. And this is nice because the period is going to give me the value for c, because I know that 2 pi times the absolute value of c gives me pi. So if I divide both sides by 2 pi, I get that the absolute value of c is 1/2. And just like the a, the c can be either positive or negative. I'm going to choose the c to be positive. Again, you could write an answer with a -c, but in my experience, it's never easier. You'll never get an easier route to an answer using a -c. So I'm just going to make it positive and move on about my day. Everybody okay with that plan? Alrighty then. The last thing we need to do then is to find a value for h and to decide whether this a needs to be positive or negative. This tends to be the trickiest part. So what I'm going to do is I'm going to pick a point from the parent function, and I'm going to compare that point with a similar point from the transformed function. So ideally, when doing this, I want to pick the point from the parent function that x coordinate is 0. So in sine, that point is 0, 0. And in cosine, that point would be 0, 1. Those are just from the key points. Now, if I go and I take a look at the graph of sine, just pull it up real quick. So 0, 0 is here. That's a midline point. But there's actually two different kinds of midline points. So notice at 0, 0, preceding that was the minimum, and following it was the maximum. If I look at this midline point at pi, I notice preceding this midline point was the maximum, and following it was the minimum. So it depends a little bit on which midline point you're using, because there's two different types of midline points. You guys see that? So I'm just going to record that 0, 0 went midline, max, as I read from left to right. That'll be important in deciding whether my a should be positive or negative. Everybody's okay with that observation? Now, it'll always be that case for 0, 0. It'll always be min, midline, max. What I'm going to do now is I'm going to find on my transform function another midline point. So I'll go up and I'll look at my graph. So I could pick any midline point. It doesn't matter. Any of those would be good ones. Let's say, for the sake of everything being easy, I picked that one at 0, 1 because the coordinates are easy to deal with. Everybody's okay with that? But it didn't matter. You could have picked any of those midline points. It would have been fine. Now let's check to see what kind of midline point that is. So notice preceding it is a minimum and following it is a maximum. Because these are the same kind of midline points, that tells me that the a I need should be positive. If they were the opposite type of midline points, the a would need to be negative. And then since the x-coordinate for my parent function is 0, the x-coordinate for my transform function must be my h. To show why that has to be the case, I know that to transform a point from the parent function to my transform function, I use this map, right? So what that says is c times the x from the parent function plus h should give me the x from the transformed function. And similarly, a times the y from the parent function plus k should give me the y from the transformed function. So in our case, we had 1/2 times 0 plus h equals 0. So h equals 0. So for sine, my final answer would be y equals 3 sine of 1 over 1/2. You could write that as 2 if you wanted. Times x minus 0. You could just write that as x if you wanted. Plus 1. I'm not going to be too picky if you simplify the function down or not. If you do, that's fine. If you don't, and you just leave it in the same form where everything is just kind of plugged in, that's okay too. Everybody's good with what we did there? Again, this second time we're doing this, right? We did this at the end of last time. Okay. So the next one, my parent function for is cosine. So on cosine 0, 1 is a maximum. So in my transform function, I'm going to pick any extreme point. So any maximum or any minimum would be okay. So I have lots of them to choose from. Let's just say for the sake of argument, I picked this one. That's at negative 2.5 pi or pi over 4. And then negative 2. And that was a minimum. Since these are opposite types of extreme points, that tells me that the a has to be negative. So in this case, my a is a negative 3. Since the x-coordinate for my parent function is 0, the x-coordinate for my transform function has got to be my h. So the h there has to be negative 4. And we're all done. So again, that was just another example of something we talked about last time. You're going to be asked to do that in this next set of homeworks that I give you to work on, so probably worth running through an example again. The last topic that we want to talk about in this first section is how to go from a description of a graph to an equation. So this is going to be similar to what we just did, but instead of getting the picture in every point in the function, you're just going to get a little bit of information about the function, maybe some limited points. So it's going to be a little bit more difficult because you have a little bit less to work with, but still not too bad. So let's just run through some examples. Let's say that we have a graph whose amplitude is 6, the period is 8, and it passes through the point -2, 7. So what does the amplitude give me?
The distance from the center line to the maximum.
Okay, which is represented by which variable? A, C, H, or K? A, but remember the amplitude is just giving us the absolute value of A, not A directly. We'll have to decide whether that A needs to be positive or negative here in a moment. What is the period going to get me? Yeah, so we know that the period is 2 pi times the absolute value of C. So I can use that to solve for the absolute value of C. And just like before, I am always going to assume that C is positive. Again, you could write an answer where C is negative, but in my experience, it never makes the problem easier and often can make it a little bit trickier. So I just choose to make my C positive all the time. Everybody's okay so far? So now, somehow, that last point is going to have to tell me my H, my K, and whether the A is positive or negative. Everybody's okay with that? And obviously, I could do this using a sine or a cosine. So let's say we're using the sine function here first. So the point from the parent function, okay, first of all, do we know anything about this point -2, 7? Do we know where that occurs in the graph? Like, is it a max? Is it a min? Is it on the midline?
Yeah, it's a max, right?
We don't know any of that,
Oh, okay. Yeah,
right? So it could be at any of those locations, right? So if I'm using the sine function, where would I want -2, 7 to occur that makes this as easy as possible? I'd want it to occur on the midline because the point from the parent function that I want to use is 0, 0, which was my midline point. So I'm going to choose that this point -2, 7 is the exact same kind of midline point as 0, 0 was. So that tells me that the A needs to be positive. Since the x-coordinate for the parent function is 0, the H is going to be the x-coordinate from the transform function. And since the y-coordinate is 0, the K is going to be the y-coordinate from the transform function. So that's everything that I need.
How's the amp?
The A value was 6, right? It's like I thought I checked that before I wrote it down. It's always possible that I just wrote, you know, did one of those and just like did something that doesn't make any sense because my brain took a break. What if we had decided to do this as a cosine function? What point from the cosine function or from the parent function is the one that I'd like to use? That point was 0, 1, which was a maximum. So since that was a maximum, I would choose -2, 7 to be a maximum. Again, since they're both maxes, that tells me that the A should be positive. Since the x-coordinate from the parent function is 0, that means the h is the x-coordinate from the transformed function. However, notice that the y-coordinate from my parent function is not 0. So that means I'm going to actually have to solve for k algebraically. So I can say a times the y from the parent function plus k is equal to the y from the transform function. So 6 times 1 plus k equals 7. So k must have been 1. And that's all we need then. So this is kind of the easiest version of one of these problems because you have a lot of freedom there. You can pick whether you want to write a sine or cosine function. You have the freedom to make that point kind of whatever you'd like it to be. Everybody's okay with that? Let's do another example. So almost the same question here, right? But we've given one other restriction to it. Instead of -2, 7 being any point, we're told that it has to be a maximum. So same work as before to get my A and C. So I'm not going to repeat those steps. Everybody's okay with that? Okay. Now, since -2, 7 is a maximum, which would I prefer to make this, a sine or cosine function if I had my choice? Cosine. I would choose to use cosine because the point I prefer to use from cosine is 0, 1, which is also a maximum. The point that I prefer to use for cosine is 0, 1, which is a maximum.
So if it didn't say you had to have it at a maximum, you probably want it sine because that'd be the midline.
If I didn't have it, stated that it had to be a maximum, then it's the previous problem,
Okay.
where the sine version was a little bit easier.
And you wanted the sign earlier because it would be like a midline?
I would use 0, 0, which was a midline point. So that tells me the A has to be 6. The H has to be -2. And then, just like before, I have to solve for my K to be 1. It's like the exact same problem as the previous one. What if I had instead chose to use sine, which is still fine? Can I use 0, 0 as my parent function point? No. Because I have to match this point to an extreme point. I'm told -2, 7 has to be a maximum. So a point from my point from my parent function I have to choose has to be an extreme point. It has to be a maximum or minimum. So for sine, the maximum is at pi/2, 1. That tells you the sign for A. But now I'm going to have to solve algebraically for both H and K. So for finding H, I have to do C times the x from my parent function plus H has to give me my x from my transformed function. So H would have to be -4 in that case. And then similarly, A times the y from my parent function plus K has to give me my y from my transformed function. So there the K is 1. So when we're finding these H's at the end, really critical that you're matching extreme point to extreme point or midline point to midline point, right? Can't match a midline to an extreme or an extreme to a midline. Mackenzie? Sure. Yep. Just like if it's a midline, I'll just always use 0, 0. And again, you could use like 3/2 -1, that's the minimum, but it doesn't really matter. It just, you'll get a different answer or whatever, but like it's equivalent, it's still correct. Is that okay? Like some other stuff changes or whatever, but still be okay. Is everybody okay with that idea? What if you're given, say, what if we're told that it has a minimum at -3, 6 and a maximum at 1043? That's it. Woof, right? What do I do with this? Well, I would start by just kind of sketching myself a little bit of a picture. So let's see, -3.6 is maybe over here, and 10.43 is maybe over there. Everybody's good with what we've done there? Just from a picture standpoint. Just like before, I'm going to find the K first. So I know the K is going to be halfway in between the minimum and maximum, right? Has to be directly in the middle. Everybody agree with that? So I'm basically looking for the number that's in the middle of 6 and 43. Everybody agree with that? Which would be the average of 6 and 43. So 49 over 2. Everybody's okay with that? Next, I'm going to find the amplitude. The amplitude is half the distance from the minimum up to the maximum. So that would be y max minus y min divided by 2. So that would be 37 over 2. Is everybody okay with that? Okay. Next thing I'm going to do is find the C. So I know from like here to here is 1 period, right? But we have really from here to here that we know. How much of a period is that piece? Just use your eyeballs. Half, right? Everybody agree with that? So I know 1/2 the period is going to equal the x-coordinate from the point on the right minus the x-coordinate from the point on the left. Everybody's okay with that? Or you can just stick an absolute value bar around the thing and not have to worry about which one's left and right. That's okay too, I suppose. And I know the period is 2 pi times the absolute value of C. So that tells me that absolute value C is 13 divided by pi. And we're always going to assume that the C is positive. And I guess the K we know already. I can put a box around that too. Okay. So all we're left to find is the H and whether the A is positive or negative, correct? which trig function would be the easier to use, sine or cosine?
Cosine.
Cosine, good. Why?
Because you're talking about a max or a min.
Because we're talking about maxes and mins. So the point I'd preferably like to use for cosine is the point 0, 1. Which is a maximum. And that would have to go to either one of the 2 points that were given because they're both extreme points, right? I'm just going to take the first one, which was a minimum. Since here the max and min are opposites, that tells me that the a has to be negative. And since the x-coordinate on my parent function is 0, the x-coordinate from my transform point or transform function has to be my h. So that's all I need. Now, suppose I'd use sine for whatever reason. Again, since we have the maxes and mins, I know I have to use an extreme point for my parent function. For sine, I guess I could use pi over 2, 1, which was a maximum. So again, that tells me that the a has to be negative if I'm matching that up to the minimum. And to find my h now, I'm going to take my c times the x-coordinate from my parent function plus h has to equal the x-coordinate from my transformed function. So that's 13 over 2 plus h equals negative 3. So if I subtract 13 over 2 from both sides, h would have to be negative 19 over 2. Just making common denominators and stuff. So that's y equals negative, 37 over 2 sine of pi over 13 times x plus 37 over 2, 19 over 2 plus 49 over 2. Does that feel okay with you guys? Again, for these problems, unless you're specified, you only really need to give one answer. I've just been writing down 2 answers in all these cases because I wanted to show what the difference is in choosing sine versus cosine and just reinforce the fact that you could do either one. Now, I would always try to choose the way in which it's easiest if it's obvious to me that like one way is going to be a little bit easier than the other. But if that's not obvious to you, just keep in mind that it doesn't really matter which one you choose, right? You may make a poor choice and have to be left with a little bit more work than the other one, but like it's usually not much more work. You know what I mean, guys? All right, let's do one more. What number are we on? Like 4 or something, right? Let's say that we have a midline point at, I don't know, 2, -3, and the fourth extreme point after that is, well, I don't know, I hadn't thought this far out. 1810. This could be gross, some of the numbers we're going to get here, but it'll be all right.
So we want to use signs as a midpoint?
Well, it doesn't really matter because you also have an extreme point. So they'll be kind of equally.
So people,
But I would start here by kind of sketching a picture. So here's my midline point. And then the fourth extreme point after that is 1810, which is up here. So if I did min, that's 1, max 2, min 3, max, that's 1, 2, 3, that's the fourth one after, so that looks like it's good. Is everybody kind of okay with what I did there? Again, I didn't know that I needed to start with a minimum for sure. I just kind of took a guess, and it worked out that that was going to be the fourth one. If it didn't, I would have started max, and then, you know, it has to be one or the other. You know what I mean? After the midline point, either have to go to the max or the min. I mean, I kind of knew which one was the right one, but everybody's good. Well, the nice part here is the K is basically free, right? I know the midline has to go right through the midline point, so the y coordinate from my midline has to be my value for K. Everybody's good with that? Okay. And I know the distance from my extreme point to my midline is my value for A. So in that case, it's just 13. Notice I don't have to divide it by 2 because I'm not going from max to min looking at the distance. I'm going from the distance max to midline, which is by itself the amplitude, right? Everybody's okay with why I didn't divide by 2 there? Okay. And then the next thing I'm going to do is figure out how big figure out the length of my period. So I know that like here to here is 1 period, right? But then I also have this much more, which is another half of a period. Everybody agree with that? So really I have 1.5 periods. So actually, instead of writing it as 1.5, I'll write it as 3/2, because it'll just make the arithmetic here just a little bit more obvious for me. Yeah, it's kind of gross there, huh? Where my C is going to be 16 divided by 3 pi. Oh, come on. My stylus just keeps stop working. Again, we always pick the C to be positive. Everybody still doing okay with what we've done here? We're being very quiet, but that's okay. So we have our C, we have our K, we have the magnitude. The last thing we need to do is figure out our value for H and whether our sign is positive or negative. So let's say that we want to do it as a sine function. So from the parent function, we're going to pick the midline point 0, 0, which is a midline point max. And from our guy, we're at 2, -3. But if I look at this midline point, this would have been max, midline, min. Everybody see that? So that tells me that the A has to be negative. But because the x-coordinate on the parent function is 0, the H is just the x-coordinate from the transformed. And that's all we need. The thing that would have been easy to miss there was the sign on my A. Had we done cosine, it's actually, I think, a little bit more straightforward here, because I know right away that here we're going max to max. So the A has to be positive, and the H has to be 18. So you got something like that. Oh, what do you guys think? I think I'm ready to be done today. Yeah.
So, just again, what do we look at when we're looking at the max line point?
You're looking at the graph
So,
and the order that things are happening.
okay, so when you're going for the min, for this one it says min, the midline point max. Are you going from?
That's always the same because it's coming from the parent function.
Okay, so it's always the same. Max, midline point, min.
So look at the blue.
Yeah.
You're always reading from left to right.
Okay. Well, where does it start? Like, how do you know where to start?
So look at the 3 blue circles.
Is it always the one left?
You're always going from left to right. So you want what happened right before your midline point and what happens right after.
Okay, well, before and after. I think that's where I was getting a little.
Thank you.
Okay. So you guys should now be able to do worksheets 2 and 3. So worksheet 2 is some descriptions and asking you to write. And then 3 is some graphs and asking you to write. Notice on worksheet 3, I asked for an answer in both sine and cosine for each problem. But in worksheet 2, it just says the sinusoid, so either a sine or cosine function is fine. You can pick whatever one seems easier to you, unless it specifies in the problem specifically. I don't remember if I had one in here that said write the cosine or what. Yeah, so there is one where I ask you to do a specific. But otherwise, unless you're told, you could just pick whether you want to do a sine or a cosine one. On Thursday, we have the asynchronous day or whatever. I made like a short, I don't know, it's like 15 minutes. And it's just me doing some more examples of this stuff where I give you a description and ask you to write the equation. If you're good with that topic, you don't even have to watch the video. So you'll just continue working on these worksheets 2 and 3, basically.
So it's just kind of like a review.
It's just a day to kind of catch up.
Okay, gotcha.
Because I know that there's a lot of details going on here, and it takes a little bit of practice. So I want to make sure we get some time to do that. For your homework check, this week on Sunday, the only thing I want is the worksheet 1. That's the only thing we'll have had a chance to talk about before I expect it to be done. Worksheets 2 and 3 are going to go into the next homework check on the 17th. And then also, I guess you could be working on 1 through 14 from the problem set, as well as the worksheets 2 and 3, I guess I should say that. But that's all going to go into the homework on the 17th, which is on the board and also reflected on My Notre Dame. If you go and you look at the assignment center and the outstanding assignments, you can see when things are due. Everybody happy on that?